In 1995, one of the recipients of the Nobel Prize in Chemistry was Dr. Mario Molina, who passed away 2 weeks ago. Molina shared the prize with Dutch scientist Paul Crutzen and American Sherwood Rowland for their groundbreaking work on a subject that doesn't get much attention these days, but probably still should: ozone depletion and the ozone hole. In 1974, Molina and Rowland published a paper showing that man-made chemicals called chlorofluorocarbons, CFCs for short, could destroy ozone in the stratosphere about 10 to 40 miles up, where most ozone resides and absorbs the sun's harmful ultraviolet radiation. At that time, the average American home had 15 aerosol cans that used CFCs. Molina and Rowland's work was crucial to enacting, in 1987, the Montreal Protocol on Substances that Deplete the Ozone Layer, which phased out CFCs globally, hailed by President Reagan as a model of cooperation between the business and environmental communities. Subsequent agreements have phased out more than 100 substances, but this time of year, we are reminded that some of these ozone-destroying chemicals stay in the air for decades. The reminder is the appearance every August of the Antarctic ozone hole, a region of exceptionally depleted ozone in the stratosphere over the Antarctic that lasts into October. At that time of year, coming out of the darkness of southern hemisphere winter, the high-altitude air is so cold that clouds form, despite the extreme dryness. Those so-called polar stratospheric clouds act as surfaces on which unusual chemical reactions take place that lead to ozone destruction. Now, ozone is most commonly measured in Dobson units. Imagine squeezing all the ozone in a column into a single layer. Globally, the average is 300 Dobson units, equal to 3 millimeters, about the thickness of 2 pennies. 100 Dobson units, about the thickness of a dime, is commonly used to define the ozone hole. This false color animation, which begins in July, shows the development of the hole this year. Blue corresponds to places experiencing ozone depletion. Purple is roughly 100 Dobson units or less, so the worst of the ozone loss. At its maximum size, the area of blue is about 3 times that of the continental United States. For historical perspective, let's go back to 1979 and look each year at October, the month which typically features the greatest ozone depletion. In general, the amount of blue and purple, that is, ozone loss, increased through the 1980s and 90s and has since about leveled off. But there's lots of variability from year to year that's related to natural weather changes. As an example, here's a closer look at September and October last year, when ozone depletion was the least in decades. But this year proved that was an aberration. Because ozone-destroying chemicals stay in the atmosphere so long, the Antarctic ozone hole is expected to keep redeveloping every year for many decades to come. The best estimate for when stratospheric ozone over the Antarctic will return to normal is sometime late in this century. Stay tuned. Our extended forecast is next.